All right, so today, guys, we're going to learn how to use coefficients in our chemical formulas. So what you guys see here, this is our chemical formula. And this number here, this arrow, this big giant 6 in the front of this formula is telling you that there are 6 molecules of H2O. Okay, and then you have your subscript that tells you the number of atoms. And then it tells you what no subscript means. Coefficient, no subscript, and a subscript. We have one H, okay, and that's bonded with an oxygen. Okay, and then we have another H because the subscript's 2. So this is one molecule of water. Okay, so if we cover up this 6, we have H2O, 2 hydrogens and 1 oxygen. Okay, so I'm going to draw another O. I'm going to draw 2 more hydrogens. Now you guys see 2 molecules of hydrogen. Okay? And basically, I'm not going to draw that 6 times. Basically, you would draw that 6 times to see all the molecules. Okay? All right, so if we do the bottom one, the first thing we want to do is our T-chart. You can do this in several different ways. Okay, so if I do the T-chart over here to this side for this bottom chemical formula, the first thing, that we're going to do is our elements. We have calcium, and then I have chlorine. Okay, Ca is one element and Cl is one element. Now, what we do with the coefficient is we distribute it. Coefficients don't need parentheses, so if we draw this Ca bonded with Cl, this is just one molecule. So we have to do that 3 times. And then we can count the atoms for our T-chart. Okay, so now we have 3 molecules of calcium chloride. So this coefficient means that there are 3 of this entire formula. So we have 3 of these calcium chlorides. Now, to count the number of atoms for calcium, we just need to count how many times we drew Ca, which is 1, 2, 3. There are 3 atoms of calcium. Now we need to count how many chlorines we have. 1, 2, 3, 4, 5, 6. There are 6 atoms of chlorine. So when we have a coefficient, we distribute it and multiply it to the subscript. We have a coefficient of 3, and we distribute that to calcium subscript, which it doesn't have 1, so that means that there is 1. 3 times 1 gives us 3, and then we distribute the coefficient to chlorine's subscript, 3 times 2 gives us 3 total atoms of calcium and 6 total atoms of chlorine. You can do the multiplying, or you can draw your T-chart. Okay? Yes. So for chemistry, we don't have to use parentheses to distribute this coefficient. When we have this big number in the front of our chemical formula, it's telling us that we have 6 of this entire compound. And so we need to multiply it by the number of atoms, which is illustrated by the subscript, so we can find the total number for all 6 molecules. Okay? So here's an example. We have the picture, and we're going to do our T-chart. Okay? Well, I'll do this one with you, and then you'll follow along. So we have a capital H, and we have a capital O. This molecule looks like Mickey Mouse. Okay. All right, so how many H's do we have? We have 2. How many O's do we have? We have 1. So I want you guys to fill in these blanks. What's the coefficient that goes here? And what subscript does each molecule, each atom or each element get? That's a question mark, by the way. Okay, so we have 1 molecule. There is 1 compound here. What is my subscript for hydrogen? How many atoms of hydrogen are there? 2 atoms of hydrogen. And then 1 atom of oxygen. Now, I wrote the ones so you guys can see it. But when we write 1 molecule of H2O, we don't write the number 1. Just, it's the same thing with the subscript. If the coefficient is 1, you don't have to write it. So the compound is really just going to look like this. Okay? We don't usually write the number 1 whenever there's 1 molecule or 1 atom. Okay, so what's our total atoms? What's our total atoms here? We have 3 total atoms, and we have 2 total elements. Okay, and then I wrote the chemical formula right here. What are our elements here? Okay, so we got to look at the capital letters. H, which is hydrogen, and O, which is oxygen. Now, how many H's do you see here total? We see 1, 2, 3, 4, 5, 6 atoms of hydrogen total. How many O's do we see? 1, 2, 3. Okay? So how would this chemical formula look? How would we write this? So we have 3 groups of this compound. So that means our coefficient, the big number in front, is going to be 3. Okay? This T-chart represents all the atoms in this entire picture, in all 3 molecules. When we write the chemical formula, the 3 tells us we have 3 groups of hydrogen and oxygen, but in each group, how many atoms of hydrogen are in each group? That'll be our subscript. Okay, some of you are getting it. So we have 3 groups of H2O. We have 2 hydrogens in every single group. So our subscript is 2 for hydrogen. And we have 1 oxygen in each group. So we just write the letter O. Okay? This is our chemical formula. We have 3 groups of H2O. H2O, H2O, H2O. Okay? And if instead of having to draw a picture every time, you can multiply your coefficient by the subscripts. So 3 times 2 gives you 6. 3 times 1 gives you 3. Okay? So how many total atoms were there in this picture? Let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 total atoms. Okay? How many different elements? Hydrogen and oxygen. There were 2. How many molecules were there? When I ask you how many molecules, I'm asking you what the coefficient is. What is that big number in the front of the formula? The number of molecules is how many groups we have. That's our coefficient, and there are 3 groups of H2O. And we already wrote our chemical formula. Okay, our chemical formula is right here. This is the chemical formula. All right, we have another example here. I'm going to draw this onto the whiteboard. So, the elements I see are H and O. Okay, I see 1, 2, 3, 4 atoms of hydrogen and 1, 2, 3, 4 atoms of oxygen. Okay, I have 2 groups of this compound. So that means my coefficient is 2. When I write the chemical formula, I write it based off of what is in one group. So in that first group, I see H, but I have 2 atoms in that group. Then I see O, and I have 2 atoms in that group. Okay? So if I cover up this coefficient, and I cover up this, we just wrote this chemical formula for this one molecule. You have 2 hydrogens and 2 oxygens. Okay? When we add that second picture, we now have 2 molecules of H2O2. Okay? 2 molecules of H2O2. And if we didn't have these pictures, what you would do is you would multiply your coefficient to your subscripts. 2 times 2 gives you 4 hydrogens. 2 times 2 gives you 4 oxygens. Okay? All right, so we have another example here. And the first thing we're going to do is write out our elements. C, Cl, and H. Now, I want to try this another way before we calculate the atoms. I have 2 molecules, right? 1, 2. So I know my coefficient is going to be 2. And I have chlorine, and I only have one chlorine in each group, and I have one carbon in each group. So I don't need to write subscripts for those two. But my next element, hydrogen, I have 3 in each group. Okay, so 1 chlorine, 1 carbon, and 3 hydrogens in each group. Okay, so this is my chemical formula. And what I want you guys to do is I want you to distribute your coefficient and tell me the total number of atoms, because you might not always get a picture. And I am going to block your pictures. Okay, there. All right, so let me delete this pretty red box. When we distribute, this coefficient tells me I have 2 chlorines, tells me I have 2 carbons, and I have 2 times 3, 6 hydrogens, giving us 3 elements and 10 total atoms. So when we look at our picture, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total atoms. We have 1, 2, 3, 4, 5, 6 total hydrogens, 2 total chlorines, and 2 total carbons. Okay, just like what we wrote in our chemical formula. Okay, so in this example, they did not give you a picture. So you had to use your coefficient and distribute it and multiply it by the subscripts. Carbon did not have a subscript, so you know that there is 1. So 3 times 1 gives you 3 atoms of carbon. And then 3 times 2 gives you 3 times 2 gives you 6 atoms of oxygen. So in total, we have 9 atoms. If we look at our picture, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 2 different elements, carbon and oxygen, and we have 3 molecules or 3 groups of CO2, okay?